Hi, I'm Hybrid Dave, and today I'm going to share my screen with you to show you how I use technology to catch the aurora. I'm a travel photographer, and I love cold places. And one of the reasons is that I love chasing the aurora, and I've done it several times now in Iceland, in Lapland, and coming up soon in the next few months I've got trips back to Iceland and off to Svalbard, not a million miles at all from the North Pole. I'll be chasing the Northern Lights again, obviously. In this tutorial, I'll be sharing my screen with you in order to share my experiences of using tech to predict the night sky. What you're seeing now is my blog and a little story about the Northern Lights that I captured in Lapland. So, the aurora can appear in many forms, from small patches of light that appear out of nowhere to streaming arcs, rippling curtains and shooting rays that light up the whole night sky, or just a portion with an incredible glow. The aurora's the result of collisions between gaseous particles in the Earth's atmosphere with charged particles which are released through space from the sun. Variations in colour come from various gases that are in our atmosphere. Let's have a quick switch over to some different ones in Instagram. So the variations in colour, as I said, are different types of gas particles in our atmosphere which the charged particles from the sun are colliding with, and the most common colour is green, as you can see. The red ones are oxygen, which is much higher up in the atmosphere. Speaking of high, the aurora can occur anywhere between 50 miles and 400 miles up from the Earth's surface. So it seems really close when you're there and when you're looking at it, but it's actually so far away it's unreal. So how do you catch the aurora using tech? Let's go over and look at some websites. So the first thing you need to do is find yourself a clear night sky. So it's always worth getting yourself on the website of the local weather service. This is the Icelandic Meteorological Office. And what we need is, as I said, a clear sky. Obviously it needs to be dark too, so you need to be there in the darker months of the year. So on this map right now, the dark colour is all the way up at 8/8 of cloud cover. Cloud cover is measured in eighths, if you didn't know that. So we can find the time that we intend to go aurora hunting. So let's go midnight Thursday night, and it's full of cloud again. We need to find the best time where we've got minimal cloud cover, and ideally we want to be as high up on terrain as possible. So we can use meteorological office's data to figure out when to go. Right now is not a good time to go. So what else do we need to know? Well, we need to know the forecast, really, and there is an aurora forecast. When these protons and electrons flow from the sun all the way through space in the solar wind, usually from a flare from the sun, they travel through and they're attracted to the Earth's magnetic field, and the magnetic field pulls these particles into the poles. It repels them from the equator and pulls them into the poles, and that's why they go straight up or straight down into the Earth's atmosphere, and that's how they collide with the particles in our atmosphere. So somebody somewhere figures this out, and fortunately there's a fantastic service called the Aurora Service. And here it is loading up now. Aurora-service.eu for European aurora, and there are other versions for other parts of the world. So the information we need here is the KP level relevant to where we are. So if we look on this map, Iceland is between KP2 and KP3. We've got Norwegian, Swedish and Finnish Laplands between KP1 and KP3, thereabouts. And it's this KP number for where we are that we need to know in order to know whether we're going to see the Northern Lights from the prediction. So if we're at the southern end of Iceland, looking down there at Vik, we need KP3, ideally. So this website will tell us all this information that we want right now. KP2 is what we have. So if you're at the top of Iceland and it's dark and there's no clouds, you'll be able to see the aurora in theory. This map underneath shows us visually where the aurora is. And there's a forecast of what the KP number is predicted to be, with a nice visual reference as well. But we can look a little bit further ahead. So this website offers us something pretty cool, the Aurora Forecast. As it says here, using real-time solar wind data from NASA's ACE spacecraft, matched with data obtained from a network of magnetometers located worldwide, we're able to forecast with reasonable accuracy how the northern lights will behave up to 1 hour in advance. Now, this website has been going for a while, and then the guys that run it know exactly what they're talking about. They're based in Finland. Right now, the aurora is 2, in 26 minutes, 2.33, 41 minutes, 2.67, and 56 minutes, 2.33. So when you're in Iceland and you're having your meal of, I don't know, puffin at the hotel, this is what you want to be looking at to see when you need to get out there, when you're going to see the aurora. There's also a handy 3-day forecast, so you can look ahead. What's tomorrow night going to be like? What's the next night going to be like? And it gives you the times in universal time, which is obviously British time, British winter time. So that's really handy stuff. If I was to go out tonight, I'll be looking between 6 and 3 in the morning, because we've got the highest of 3. If we're in southern Iceland, that's the number we need. We need it to be a 3. So what else have we got? Let's go and look at some apps. This app, Aurora Forecast, provides us with similar information. It will tell us what's going on, or what the probability is of things happening. So at high latitudes, which is closer to the North Pole, obviously, there's a reasonable chance of things being active or having a storm. It gives you the KP numbers, and it gives you all the space data. Personally, I don't look at the space data, I look at the KP numbers and the predictions. There's another app we can use, Aurora Now. There's a whole plethora. And it's telling us what's coming off the sun, the percentage at the top there of seeing the aurora right now where we are. Well, I'm in London, and it's 5:30 in the afternoon. So 0%, absolutely nothing, even in 15 minutes. But it gives us the 3-day predicted KP forecast, and it gives us a color coordinated reference. So that's pretty handy stuff. When we shoot the aurora, we need to have a nice fast aperture, a nice fast lens wide open, so that we can capture as much light as we possibly can. Because if we're going for longer exposures, we might get some star blur, but there are a variety of ways to shoot the northern lights. You can shoot for a nice silky effect. You can shoot long exposures with a low ISO, because they're actually surprisingly bright. And if you want to get something a bit more detailed, you need to shoot at a nice high ISO. Let me see if I can find an example. A nice high ISO and shorter time. Something like these ones here. The two smaller ones. That's a high ISO and a shorter exposure. You can find more information about how to do this all over the internet. My tutorial today was to teach you that there is tech that you can use to figure out when the northern lights are going to be appearing. So thanks for joining me, thanks for sharing my screen, and if you want to find this blog, it's at hybriddave.com.